Hello everyone, thanks for joining us today. My name is Josh Buckler and I'm the Director of Business Development here at Help It Systems. I work closely with our client base and development team to continually understand and address data quality challenges on a day-to-day basis. Just a quick introduction, Help It Systems is one of the early pioneers in the data quality industry, which is to say that we have been refining match and cleansing concepts and strategy for more than 20 years. All of our products integrate closely with SQL Server, so contact data quality within SQL Server has been an area of focus for us as an organization. In just a moment, I will be handing this over to Ben Gallagher, our Systems Development Director, who has been working with our team internally to understand DQS and how it can help our customers get closer to their contact data quality objectives. As Ben will discuss, there are some data cleansing applications for DQS, and this webinar is really designed to get you started on that process and help you navigate some of the nuances we found along the way. Many of the organizations that we work with come to us to resolve their contact data quality issues. We often explain to them that resolution is more than just cleansing, it's also about issue prevention, which led us to a concept we call the data quality firewall. The data quality firewall is a strategy designed to identify the best means to find and resolve data quality issues at every capture point and allow for organizations to take advantage of their data with confidence in real time. Most companies need to deal with information coming in from several sources that can be broken into two primary segments: transactional and batch. Transactional would include anywhere that there is a single record entry, like a customer website, a call center, CRM, and a store. The ideal time to fix data quality issues with these types of entries is in real time while interacting with the customer or end user, because there are data issues that can only be fixed by the customer providing more information. For example, if someone were to provide an address in a web form like 100 Main Street, but there's both a valid North and a South Main Street, only the customer can confirm which is correct. Batch, on the other hand, includes all data file imports, EDI feeds, bulk lists of transactions, and potentially even data appends. Since the opportunity to interact with a customer or end user has already passed, the most that can be done from a data quality perspective is to clean the data as best as possible prior to importing the new information into your master data and flag bad or incomplete data thereafter. So with that brief introduction, I'll turn it over to Ben to walk you through the agenda and proceed. If you'd like to interact with Help It or one another during the webinar, you can join the conversation by using hashtag DQSintro on Twitter or send us a direct message to @HelpIt. We'll also be available to answer any questions throughout the presentation in the webinar chat feature.
Okay, thanks for the introduction, Josh. So today we're going to provide an overview of the DQS product, which is new in SQL Server 2012. We're going to use a few examples to illustrate how you might go about creating a simple knowledge base, how you might use that to clean your data, and then when we cover that, we'll have a look at creating a matching policy and how you can use that to identify duplicates within your database. So we're going to start out with a few slides, but then we'll quickly be shifting to demonstrations of DQS at fairly regular intervals, and hopefully that way you can get a flavour for the product, how it works, and how you might be able to use it. As we're going, I'll try and highlight any sort of obvious limitations that we've uncovered, but just bear in mind that the product's pretty new and we're learning as we go along, but we'll try and answer any questions as best we can. We're aiming to run through the webinar in around about 30 minutes, and hopefully it's going to be beneficial. But with that, we'd better get moving. Okay, so the first thing we're going to be looking at are knowledge bases and domains and how to create them in DQS. The knowledge base is really the heart of the product, and it's the most powerful feature. Knowledge bases are collections of knowledge about related data domains that allow DQS to make intelligent decisions about the data that's being processed. So for example, you can use it to change things like ST to street or Bob to Robert, or you can use it to correct common misspellings. For example, you might create a knowledge base for names and addresses or for product models and descriptions, and the domains you might create include individual elements such as first name, last name, state, zip, city, that sort of thing. The domains within the knowledge base represent key fields within your data, and that basically allows DQS to get an understanding of the structure of your data. Just note though that DQS does expect you to create the knowledge base, and you need to populate it as well with appropriate values before you can start processing. Okay, domains can be used to define data types and validation rules. As a domain is passed, there's a number of tricks that DQS can perform to improve the quality of the individual records. Domains allow incoming data to be normalized to improve matching. for the data to be properly cased, spell checked, common errors can be corrected. And another neat trick is to apply synonyms. So, for example, the names Bob, Bobby, Rob, or Robbie could all be mapped to Robert, and that's quite important when it comes to matching later on. So that Bob and Rob, for example, can be matched as a first name. Okay, term-based relations allow a simple find and replace to occur as domain data is processed. So, for example, you could replace bool with boulevard. Domains are single entities but can be combined to create composite domains, and this is where it gets a bit more interesting. So, for example, you could create a composite domain for name consisting of first name and last name domains. Composite domains allow us to create cross-domain rules. So if you had a composite domain for name comprised of a first name and last name, then you could set up a rule that says that both first name and last name must exist for the record to be valid. When defining rules, you've got some flexibility there too, because you can use regular expression matching. And I've got an example later on where I'll show you how you can use a name quality composite domain to output a quality score based on the contents of your title, first name and last name data. This is pretty cool, but having done that, you couldn't then create an addressee composite domain for combining your name data into one field, since a domain such as first name is only allowed to be used in a single composite domain. Having said that though, you could create a second composite domain rule to do this. DQS can pass the composite domain data using reference data, where it can pass it in order, or using defined delimiters. So if you build up enough reference data, then the parsing is going to be improved, but obviously that's going to be a bit time consuming, but it does give you the ability to fine tune your system as it processes more data. Okay, then let's have a look at DQS and see how we could go about creating a knowledge base in practice. We'll create a few domains in our knowledge base as well. Okay, so let's open up DQS and see how you go about creating a simple knowledge base. Firstly, you get to give your knowledge base a name, a description. You've also got the options created from an existing knowledge base, or by importing from a DQS file if you're transferring a knowledge base that you created previously. Maybe you created one on a different server, for example. In our case, we're just going to create a knowledge base from scratch. You've got several options: domain management, where you can define the data types that make up your knowledge base; knowledge discovery, which we'll come onto later, but it's a tool that allows you to import sample data; and matching policy, again, we'll come to this later, but once your knowledge base has been set up, you can define matching rules to allow you to identify matching records. So we're going to go ahead and choose domain management. The domain management screen is, as its description says, for managing your domains. We can create domains and composite domains. Composite domains are comprised of multiple domains and allow you to create cross-domain rules. So we'll start out by creating a few simple domains, and then we'll add a couple of composite domains too, and that way you can get to see what these do. Firstly, we'll add a domain for premise. When you create a domain, you get to give it a name and a description, and you can also say what kind of data DQS should expect. You can also tell DQS whether to make corrections using a set of stored synonyms. For example, you might want to change Bobby to Robert. There's several other options too, such as whether it's to ignore punctuation, whether you want to proper case the data, a dictionary to use, depending on your language, whether to apply spell checking, and whether or not to use syntax error checking algorithms. By default, DQS performs some basic checks on string domains and may attempt to change the data if it determines that syntactically it's not correct. Okay, so now I'll add some domains for street, first name, last name, and then title. So first name, and then last name, and finally we'll add title. Okay, let's go ahead and create a composite domain now, and we'll give this domain a name of address1, and we'll make it comprised of the domains premise and street. So by default, DQS will use a space when it's passing the address1 data, and then it's going to split that data into the two domains that comprise the composite domain, in this case premise and street. I'm also going to add a domain called name quality and a composite domain that uses it. And we'll use this later on to demonstrate how we could use a composite domain to implement a very simple name quality algorithm. So basically it's going to give you a score depending on how good the name data is in your database. And finally, I'm going to create some domains now for zip and the other address lines that might be present in our data. So if you can just bear with me while I do that, and then we'll move on. Okay, so I've added fields for zip, address 2, address 3 and company. For each domain that you create, you've also got the option to use or add reference data using an external service provider, but of course you have to pay for these. Example might be using a service provider maybe to validate address data. You can also apply simple and complex domain rules, and we'll go into that in a bit more detail later on. And you can also manually add domain values, and these are values that will be considered as correct and valid, but you can also specify corrections, so maybe you've got misspellings you want to handle, for example. Finally, term-based relations, that's just a very grand name for find and replace, and that can be applied to your domain data as it's being processed. So once it's published, the knowledge base is then available to be used in any DQS projects that you may create. And we'll give you an example of how to do that a bit later on. One brilliant feature in DQS is the knowledge base discovery functionality, and this allows you to preload your knowledge base with values. So that could be a list of names or states or some other list of common values for a specific data field. Microsoft have also released a default knowledge base, and that's got some common data in it as well, such as country names and abbreviations, US states, etc. There will also be more third-party and shared data sources with standard industry-based information as time goes on. As DQS processes your data, you'll have the option to manually review the processing results and to add new values into the knowledge base and tune the processing for future runs. And it's also very much a product that will gradually improve the more data it processes, but it will definitely need appropriate resource to manage and implement this. Okay, so I think the best thing to do is have a look at it. So I'm going to give a quick demo now of how you might use the knowledge base discovery, and then we'll move on and look at how you'd actually go about using your knowledge base with a real DQS cleansing project. Okay, so let's have a look at the knowledge discovery tool in DQS. It's pretty cool, and it allows you to help build your knowledge bases. So we'll go ahead and right click on our knowledge base and just choose knowledge discovery this time. There's a variety of different data source input formats that you can use, things like Excel, but for example I'm going to run here, we're just going to use a simple database table. It's one I prepared earlier, yeah, in this case it contains just a set of sample first names. So as we've seen before, we'll choose the table and map the fields. Okay, so we'll click next and kick off the processing, and it should run through pretty quickly. Looks like it has. It's found 22 unique names, and we can have a look at those names. You can see that several of the names were found more than once. You've got options there to specify corrections as well. So there you go, we've loaded in our first knowledge base. Okay, so if we go and publish the updates that we've made to our knowledge base, then basically any new projects that we create that use this domain will have access to this data. So what that means in reality is if you map a field to the first name domain, then the data in that field will get validated against our first name knowledge base. So only names that are in our knowledge base will be marked as valid So you can then use the results of that and do any processing that you want to do. Okay then, so to summarise, knowledge bases are really good at making minor corrections, normalising names, product names, that sort of thing. The knowledge discovery feature is a great way of building up your initial knowledge base, and then when processing data sets going forward, you can manually review the results and tune your knowledge base, and in that way it'll become more and more effective. But that process can't be automated, so you are going to need someone to do that manual review, and that could be quite an overhead on someone's time. But having said that, it's pretty easy to use, and you don't need to be an expert on SQL Server or DBA. So you could get the right member of staff who knows most about the products involved in creating that database, rather than leaving it to the DBA, who obviously may come with a more technical rather than a business-focused mindset. Okay, so once you've created your knowledge base and set up your domains, you'll want to start using it to do some actual cleansing. And the easiest way to demonstrate that is to actually go back into DQS and have a look at how you do that. Okay, let's go back to our domain again and look at setting up a few simple domain rules. So again, we right click on the domain and this time choose domain management. And again, we can go back now and edit what we created previously. Okay, so the first rule I'm going to add is to our premise domain, and this rule is going to say that any valid premise must consist of only numeric data. The way we can achieve this is to say that data in the premise domain must match a regular expression, and then we'll add a simple expression to indicate that the field should contain numbers. Okay, let's have a look at how we can use a composite domain to implement some basic name scoring. So that's scoring based on the quality of the data in our name fields. So this time we're going to open up the NQScore composite domain we created earlier. This domain was comprised of title, first name and last name data. This time though we create a composite domain rule which states that if our title, first name and last name fields are all populated, then put the numeric value 10 into our name quality domain. You can also create multiple rules here, so you could set up different rules that say that, for example, if all of the name fields are empty, then put the score 0 into your name quality domain. Each rule that you create, you have to give it a name. The description is optional, but I'd recommend putting something meaningful in there, just from a point of view of maintenance. If you come back to modify the domains, several months down the line, it'll be a helpful hint as to what's going on, because some of the rules can get quite complicated. I'm actually going to be a bit naughty and ignore my own advice. This is just a demo and it's a very simple rule, but I would definitely recommend that you normally put in a description. Okay, now let's extend our first name domain, and we can add a couple of synonyms here for Robert. So I'm adding synonyms for Bob and Bobby, and that basically means that those two names will be normalised now to Robert in the output from our processing. Finally, let's change one of our address domains, and this time we can add some term-based relations for Mississippi and Missouri to correct some misspellings that might occur. Another way you could do this might be to use a synonym instead, but you'd need a dedicated state input field to do that. Okay, having done all that, we'll finish up and publish the changes to our knowledge base, and then we'll have a go at using them. Okay, so let's go ahead and create a new project, and we'll tell DQS that we want it to use our demo knowledge base. That's the one we've just created, and we'll also tell DQS that we want to edit the cleansing attributes of the project. Okay, so now we can go ahead and choose our database and select a table. I've got a table called example data, and that's got some names and addresses in it. I'm now going to go ahead and just map all these fields, so just bear with me for a minute while I do that. And in a second I'm going to map the address 1 field to the composite domain for address 1, and I'm also going to map the name quality score field to our name quality score domain, and this is where the output from the NQ score composite domain is going to get written. Having done all that, we can move ahead and run our processing. So I'll click on the start button and off we go. It should run through relatively quickly. Okay, so we'll go ahead and click next now it's finished, and we'll have a look at our results. Firstly, in our address 1 results, we can see that where DQS has not recognised any numeric value in the first part of our address data, it's marked the records as invalid, and that's based on the rule we put for our premise domain. We can also see records it's marked as correct. These are showing up as new records, and they've actually been added to the knowledge base in the background. And in this case, the numeric data is present in the first part of the address field. My example is fairly crude, but I'm sure you can implement a lot more intelligent rules to try and extract premise data. But it will be a bit tricky, as address data is often not well structured, depending on the source of the data. If your data is already well structured, then the DQS parsing and correcting will work pretty well. But if your data is not well structured, then it may be a bit harder. Okay, so if we look at our address 3 column, we can see there are a couple of corrections that have been made to misspellings of Mississippi and Missouri, and that's based off the term-based relation rules that we added in our knowledge base. Then with our name quality domain, we can see that Bob's been changed to Robert due to our first name synonym that we set up, and we've also generated name quality data scores for 34 of our records. These are the records that had titles, first names and last names, and they've all been given a score of 10 according to our rule that we'd set up. Okay, next we can actually review the data that will be output, and we also get the option to choose a table and database to tell DQS where to output the data. Each domain has got a domain source and a domain output value and a domain reason that you can use to query whether data is valid or not. So using this information, you could pull out your invalid data for manual or automatic correctioning. So in a second, I will open up a table in SQL Management Studio, and you can have a look at the results that have been output from DQS. Okay, so we have a look at the results that have actually been output by DQS. We can see that Bob's been corrected to Robert according to our first name rule. We can also see some of our address 1 output and where it's failed and passed the composite domain rule. In fact, we've got a rule on premise, and that's the reason that things have been passed or failed in this case. We can also hopefully see a couple of corrections for states for Missouri, there we go, and also for Mississippi, I think. Yep, and you can see the reason term-based relation. And we can also see the name quality score being output of 10 for various records where the name data and title was all populated. And if we scroll across, we'll see the premise where that's been passed, and you can see where it's failed because the first word was post and it wasn't numeric, and you can see where it succeeded as well. So hopefully that's given you an idea of the kind of rules you can set up within DQS and how you can use them. It's a pretty cool tool, but it really is a starting point for getting your data clean. Okay then, to summarise, having created your DQS knowledge base, this then becomes available to be used by DQS data cleansing projects. Multiple projects could be created, and they could all use the same single knowledge base if you wanted, or you could have multiple knowledge bases. If you subsequently go back and amend your knowledge base and then republish it, existing cleansing projects don't seem to be able to pick up on the changes. This is actually a little bit annoying, especially in the early stages when you're developing your knowledge base and you may be making frequent changes. DQS provides a very nice, easy to use interface to create these projects, so you don't need to be a SQL Server expert to get started. Processing results can be reviewed within DQS itself in the user interface and then written to your database, and you can then write your own routines if you like to use those results and clean up your original source data tables. So DQS provides the ability to create a matching policy within your knowledge base, and this is a set of rules that can be applied to identify potential duplicate records within a data set. Matching can either be fuzzy or exact. Just keep in mind that the fuzzy algorithm being used is not phonetic, so names that sound the same but are spelt very differently are not going to match. The grading of matches is something that will take a fair amount of experimentation, but the aim would be to try and establish clear rules for automation so that you're not accepting false matches or missing too many true matches or having to review too many matches manually either. How successful you're going to be is going to be constrained by the nature of your data as well as the time and effort that you've got available to put in. So the best way to have a look at this matching is probably to go back into DQS and create a matching policy. Okay, so let's have a look at how you can implement a basic matching policy within the knowledge base, the one we created earlier. Again, right click on the domain, but this time choose matching policy. Okay, so now we're going to choose a database and the table, and then select the fields that we want and the mappings against our domains, and these are going to be the fields that we're going to use in our matching rules. So I'm selecting first name, last name, address one, I'll choose zip, and we'll map the domains now, first name, last name, address one composite domain, and my zip domain, and then we'll click next. Okay, so we can go ahead and add our matching rule. Basically it's a combination of scores for various domains in your data. So I'm adding scores for first name and last name. I'm going to add a score on premise. In fact, I'm going to mark premise as a prerequisite, which means it must match. So it's got to be an exact match for this rule to apply. And I'll also add a score for zip and street as well. The score percentage total has to add up to 100%, and you have a minimum matching score percentage of 80%, although that can be customized. There's an administrative tool with DQS if you've got the right user access level, which allows you to change that. So we'll kick that off and we'll get some results and have a look at those. Okay, so we've actually only found 2 matches, which is not very good because I know for a fact that there's more matches than that in this data set. So we're going to have to go and review our matching rule. We can see from these 2 records though that some of our first name data is in fact just initials and not complete names. So we may be able to get some more matches by using a rule that scores matches based on the first character of the name. Obviously it's a bit contrived. Just because the first character of a name matches doesn't necessarily mean that the complete name is a match, but it should illustrate the kind of matching process that you need to follow in DQS. And it also shows that your data really needs to be quite granular if you're going to get the best out of the matching process. So within my table, luckily I've actually already got an initial field. So we're going to go and use that, and we'll map that into our first name domain. And we'll try the matching, and we should get quite a few more matches this time. Okay, so this shouldn't take too long to run. There we go, we've got quite a few more matches this time. You can see them there, and they're all given various different scores depending on how good DQS thinks the matches are, and those scores are obviously made up from the domains in your matching rule. This is quite a useful little tool actually, because it lets you preview your matches, tweak your matching rule on a subset of your data. So I've actually created a project already where I've used this rule, and I've output some data into a SQL Server database. I've output the matching results, I should say, and we can have a look at those and compare those with the source data and see how good those matches are, and see what matches we've got and what matches we've actually missed. These are the product. Okay, so if we have a look at the table here in SQL Management Studio, these are the results that I've output from DQS, and as you can see they all look pretty good results. Just highlighting a few there for you. You scroll down, you can see the unmatched records at the bottom of the output. If we compare that with the actual source data, and I've ordered this by last name so you can see quite easily where there should be matches. So J Acevedo, the address 1 data there is actually in the address 2 field in the second record, and we'll see that because of that, DQS couldn't pick that up as a match, which kind of really highlights the point that your data needs to be really well structured and granular to get the best out of the matching process. The same thing here with these DQS records. Again, the address data is in address 1 in one record and address 2 in the other. And again, DQS won't pick that up. If we look down here, we've got 2 Dayton records, D-A-Y-T-O-N. You can see the address data is the same. And we're going to look at the source data. We can actually see we've got a Dayton spelled differently there, but it sounds the same and the address is all the same. So it should really be a match, but DQS can't pick that up. Presumably its algorithm is not phonetic. And there's 2 records here, Griffiths and Griffiths. They look like they should be a match, but because of that address 1 data being slightly different, I think that's the reason. Anyway, DQS couldn't pick that up as a match. So, I mean, that gives you an idea of the kind of matching that you can do. DQS is pretty easy to initially configure, and it's a pretty good tool, but it is going to miss certain matches, and if your data is not very granular, then the matching is going to struggle a bit. The other thing you'll notice is that DQS is really focused on finding records within a single data set, but not for overlapping 2 different data sets. So that is to say, to find records that are in one data set that are also in another data set. So that's quite important, because quite often in a business you'll have an existing universe of data, and you may have some sort of update file that's coming in and you want to match that against your existing universe. And that's kind of one scenario that DQS doesn't cater for kind of out of the box. You might be able to work around it, but it's obviously going to be a bit of extra work. So in summary, DQS provides useful matching functionality, but it will miss some genuine matches that more sophisticated matching engines could pick up. There's no obvious out-of-the-box way to identify duplicates between 2 different sets of data, but you might be able to work around this by loading both sets into a master table and then using some kind of source ID field. You can't use DQS to identify if a single record exists within your database. So, for example, sometimes people might want to use matching as a duplicate prevention tool to check whether a single record already exists in the database, but DQS is very much a batch cleaning product, and so it doesn't really lend itself to that kind of thing. Data really needs to be granular and well structured as well for fuzzy matching to be effective. So this is really a key point, at least for contact data. You're simply not going to get decent matches without having split your data into its component parts. So what are the performance and hardware requirements for running DQS? Microsoft provide a couple of tables in their documentation that gives an illustration of what you can expect. Just bear in mind that if you're running the product on a remote database, then the network traffic may be quite high, so bandwidth can be quite important. We can see from the table that you could expect to process maybe 1 million records in about an hour from a matching point of view. But that will kind of vary a little bit depending on how many matches are in the database and how many rules you're running. In terms of hardware requirements, DQS is pretty memory intensive, and if you're running less memory than recommended, then processing speed will reduce quite noticeably. In fact, I've not actually been able to process 5 million records on a machine that's got less than 16 gigabytes, so the requirements are really pretty rigid. So, to summarise, a variety of common data sets are gradually coming on stream and can be loaded through the knowledge discovery feature. Knowledge bases can be tuned over time, but there will always be somewhat of a need to create and update knowledge bases around your specific business needs, and you'll need to be prepared to put that time and effort in. The more depth your knowledge bases contain, the stronger your data quality processes will be. Similarly, creating and testing domain rules and composite domain rules can be complex and rather time consuming too. DQS is really better suited to more structured data, such as typical product data, than it is to typical contact data. For contact data, DQS could be used for applying corrections and standardizations that are specific to the database being processed. The data can then be passed to an application that focuses on challenges more typically found with contact data. We've also found that processing large volumes of data using DQS is quite resource intensive, and there are faster products out there.
Perhaps one of the biggest limitations to DQS is that it cannot completely address the challenge of acting as a data quality firewall. From the transactional perspective, DQS does not yet have a real-time integration feature, so the power of the standardization and cleansing techniques that Ben has demonstrated today must take place after information has already been added to SQL Server. On the batch side, incoming data and staged information can be reviewed against the knowledge base for standardization and consistency, but DQS cannot match the incoming batch data to your master customer file. Therefore, in order to link new information, you would need to reprocess the entirety of the master data with the new batch table in a single process each and every time. So while DQS has a lot of potential and with iterative learning can do a great job of cleansing a single source of information like your customer table, it does fall a bit short in providing you a methodology to keep the data clean and available to the business in a real-time and accurate fashion. The best way to incorporate DQS into your data quality firewall strategy is instead to view the solution as a means to support the maintenance and cleanliness of your data by policing the data rules that are already enforced by other technologies like SSIS and third-party applications. If anyone has any further questions, they can always email them to Ben or me at the above location. Helpit does offer a variety of data cleansing tools that pick up where DQS leaves off. If you are not sure how to get your project started or need additional consultation to determine how to best take advantage of DQS, you can reach out to me and we can provide a complimentary consult and data evaluation that some of our clients have found very helpful in determining how to move forward. Thank you so much for your time today.